In 1921, an Austrian airplane builder designed a car that wouldn't be matched aerodynamically for almost 60 years. It had a drag coefficient of 0.28. Most cars of its era were closer to 0.6. Volkswagen didn't hit that number until 1988. With their Passat, the car was a sensation. It sold roughly 100 units, and then the unsold ones were literally set on fire in a movie. This is the story of the Rumpler Tropfenwagen, the world's first aerodynamic production car. A machine so far ahead of its time that when Volkswagen engineers finally measured its drag in a wind tunnel in 1979, they assumed their instruments were wrong. They weren't. To understand how this car came to exist, you need to understand the man who built it, and you need to understand the world he was building it in. Because this isn't just a story about an unusual car. It's about an engineer who kept getting pushed out of one industry and into another, each time dragging revolutionary ideas with him. And it's about what happens when you build something the world isn't ready for. Edmund Rumpler was born in Vienna in 1872 into what was then the Austro-Hungarian Empire. He studied mechanical engineering at the Technische Hochschule in Vienna, graduating in the mid-1890s. By 1897, at just 25 years old, he was already collaborating with Hans Ledwinka on the first Tatra car, the Poseidon. That's right. Before he ever built an airplane, before he ever designed a teardrop car, Rumpler helped create one of the earliest automobiles from what would become one of the most storied car companies in Central Europe. By 1902, at the age of 30, he had left Daimler, where he'd been working as a designer, to become the technical director of Adler, one of Germany's prominent automobile manufacturers. At Adler, he designed the first German engine to combine the motor and gearbox into a single unit. Think about that. Every car on the road today has an integrated powertrain. Rumpler did it first. In Germany, in 1902. A year later, in 1903, he patented a swing-axle rear suspension system. That same patent would later be adopted by Ferdinand Porsche for the Volkswagen Beetle, the Porsche 356, and the Porsche 911. It also ended up in the Chevrolet Corvair decades later. The Austin Mini used his transaxle concept, so already, before the man ever touched an airplane, his automotive ideas were seeding future engineering for the better part of a century. Then, the Wright brothers flew at Kitty Hawk, and Rumpler's world changed completely. He quit Adler in 1907. The pull of flight was too strong. By 1908, he had set up a small design office in Berlin on Gitschener Strasse, working on aircraft components and principles. By 1910, he had founded Rumpler Luftfahrzeugbau at Berlin-Johannisthal and became the first aircraft manufacturer in Germany. His breakthrough product was the Rumpler Taube, a monoplane based on a design by the Austrian inventor Ego Ettrich. The Taube, which means dove in German, had wings inspired by the shape of the Zanonia seed, a tropical plant from Java whose seeds glide with remarkable natural stability. The airplane looked like a bird. It flew like one too. Stable, predictable, forgiving. The German military loved it. The Prussian army started ordering them in 1911, 10 that year, then 48 the next, then 73 the year after that. The Taube became Germany's first mass-produced military aircraft, used for reconnaissance, light bombing, and training. In November 1911, an Italian pilot flying a Taube variant dropped the world's first aerial bomb from an airplane over Libya during the Italo-Turkish War. The airplane that changed warfare forever was built on a design Rumpler had licensed, refined, and mass-produced. The Taube had problems, though. In 1913, one lost a wing during Army maneuvers and killed both airmen. The military ran structural tests and found the safety factor was worryingly low, just 3.4 Gs before failure. Modern light aircraft need at least 3.8. By the time the war started, biplanes were replacing it at the front. But Rumpler had already moved on to more advanced designs. Now, the licensing arrangement with Ettrick was messy. The original agreement said the planes should be called Ettrick Rumpler Taubes. Rumpler decided his name sounded better first. Then he stopped paying license fees entirely after Ettrick's German patent was invalidated. Ettrick sued. He won. But the damages were small compared to what Rumpler was pulling in from military contracts. Not Rumpler's most honorable moment, but an effective business decision. By the time World War I was in full swing, Rumpler's factory employed 3,300 workers and was producing reconnaissance biplanes, fighters, and bombers for the German war effort. Streamlining became a Rumpler trademark. His aircraft were known for clean designs that prioritized drag reduction and speed. The man understood airflow at a fundamental level, not just theoretically, practically, in a way that would matter enormously for what came next. Then, Germany lost the war, and the Treaty of Versailles obliterated everything. Signed in 1919, the treaty prohibited Germany from manufacturing powered aircraft, full stop. Overnight, Rumpler's entire industry was illegal. His factory at Johannisthal, 3,300 employees strong, was suddenly useless for its intended purpose. The tools were there, the knowledge was there, the skilled workforce was there. But the product they existed to create was now forbidden by international law. So Rumpler went back to cars. But the Germany he was returning to was not the Germany he had left. The Weimar Republic was in economic chaos. Hyperinflation was building. The country was humiliated, broke, and struggling to find its footing. In this environment, starting a new automotive venture was either visionary or insane, possibly both. But Rumpler had something no other car designer possessed. He had more than a decade of aerodynamic knowledge from designing military aircraft. He understood airflow, drag, lift, pressure distribution, and streamlining in ways that no automobile designer of that era could approach. He had access to the Aerodynamics Research Institute in Göttingen, one of the world's premier wind tunnel facilities. And he had an idea that was, conservatively speaking, about 40 years ahead of the entire automotive industry. He was going to build a car shaped like a raindrop. The project received backing from Berlin publisher Hans Lachmann Mosse, giving Rumpler the resources to bring the concept to production. The concept was called the Tropfenwagen. Tropfen means drop in German. The car would be shaped like a falling water drop. Rounded at the front, tapering to a fine point at the rear. Maximum aerodynamic efficiency, minimum drag. Every other car on the road in 1921 looked like a horse carriage that had traded its horse for an engine. Boxy, upright, flat-faced, aerodynamic as a garden shed. The drag coefficient on a typical car of that period sat somewhere around 0.6 to 0.7. Rumpler wasn't shooting for incremental improvement. He was aiming for a completely different paradigm. He built it in his small Berlin factory near the Johannisthal airfield, repurposing the same facilities where Taube monoplanes had been assembled during the war. He tested scale models in the Göttingen wind tunnel, something that simply was not done with automobiles at that time. Wind tunnels were for airplanes, period. Nobody tested cars in them. Rumpler didn't care about the convention. He was an airplane man building a car. He was going to use airplane methods. He was going to apply everything he knew about making objects slice through air with the least possible resistance. The result was unlike anything anyone had ever seen on four wheels. On September 23, 1921, at the Berlin Motor Show, the first major automotive gathering since the war ended, Rumpler unveiled the Tropfenwagen. The crowd was baffled. Every other car at the show was some variation on a box with wheels and exposed mechanical bits. The Tropfenwagen looked like a submarine had been crossed with a Zeppelin gondola. It had a curved roof that swept smoothly down to a pointed tail. The windscreen was curved in a single plane, a world first for any production car. The side windows were curved too. The headlights were integrated into the body rather than mounted on protruding stalks like every other automobile of the era. A single large central headlight gave it a strange, cyclops-like face. The wheels were covered with smooth disc covers instead of exposed spokes, eliminating the drag that spinning wire wheels generate as they churn through the air. Even the mudguards were redesigned as horizontal slats, minimizing frontal area rather than following the traditional arched shape that catches air like a scoop. And then there was the layout. The driver sat alone at the very front, dead center, for maximum forward visibility. Think McLaren F1, 72 years early. Behind the driver, at the widest part of the body, sat 4 passengers on 2 rows of seats. All passengers rode between the axles for maximum ride comfort, and behind them, just ahead of the rear axle, sat the engine, a mid-mounted power plant, in a production automobile in 1921. Nobody else would attempt this layout in a road car for decades. The engine itself was a genuine oddity. Built by Siemens and Halske, it was a 2,580 cubic centimeter W6, not a V6, a W6, 3 banks of paired cylinders, all working on a common crankshaft with overhead valves. It produced 36 horsepower. That's it. 36. But here's the thing. Because the car was so aerodynamically efficient, 36 horsepower was enough to reach 110 kilometers per hour, roughly 70 miles per hour. For context, most cars of that era with similar power output struggled to reach 50. The Tropfenwagen was doing 70 on 36 horses. That gap is pure aerodynamics, nothing else. The engine, transmission, and final drive were all assembled together as a single unit and installed as one piece, another echo of Rumpler's integrated powertrain thinking from his Adler days. The rear wheels used his own patented swing axle suspension. The front used a beam axle with leading leaf springs. The whole car weighed 1,400 kilograms, about 3,086 pounds. It could seat 4 or 5. And underneath it all was a smooth undertray and a rear diffuser. A diffuser in 1921. Ground effect principles wouldn't become standard in motorsport until the late 1970s. Rumpler was using them before most automotive engineers even knew what a boundary layer was. The car was a technical masterpiece. The problem was literally everything else. The W6 engine was complicated and notoriously unreliable. 3 banks of cylinders sharing one crankshaft created maintenance headaches that ordinary mechanics couldn't solve. Cooling was a catastrophe. With the engine buried in the back of the car under all that tapering bodywork, heat had nowhere to escape. The radiator was poorly positioned and inadequate for the task. In daily driving, the engine overheated constantly, especially in traffic where there was no airflow to help. The steering was vague and unsettling. Drivers accustomed to conventional front-engine cars found the whole experience disorienting. The weight distribution was different. The turning behavior was different. Nothing felt familiar. And there was virtually no luggage space. The teardrop shape left no room for suitcases. This was a fundamental packaging problem that Rumpler never fully solved. Later models tried adding a luggage compartment directly over the engine. This was the engineering equivalent of putting a wool blanket over a campfire. The cooling problems got significantly worse. Then there was the way it looked. In 1921, people expected a car to look like a car, tall, upright, dignified, with a visible radiator grille and proper fenders and a separate trunk. The Tropfenwagen violated every expectation. The curved glass, the rounded nose, the tapering tail, the single enormous headlight. It looked alien. People were genuinely unsettled by it. They didn't trust it. They didn't understand it. And they absolutely did not want to be seen driving it down the street. Remember, this was the early 1920s. Cars were status symbols. They were supposed to look imposing and traditional. The Tropfenwagen looked like the future, And in 1921, people weren't buying the future, they were buying familiarity. If you're enjoying this, hit subscribe. We cover stuff like this every week. Okay, back to it. Production numbers tell the brutal truth. About 100 Tropfenwagens were built between 1921 and 1925, roughly 20 per year. For a production car, that barely registers. Most of them ended up as taxis in Berlin, not because taxi operators had a sudden appreciation for aerodynamic efficiency. They liked the high ceiling, which made it easy for passengers to climb in and out. The rear-mounted engine meant no drive shaft running through the cabin, so the floor was completely flat. Easy entry, smooth ride, decent taxi, terrible consumer product. Rumpler tried to save it. He introduced a touring torpedo version with more conventional mudguards to soften the alien appearance. He built a Pullman limousine variant with more interior room and dedicated luggage space. In 1924, he replaced the troublesome Siemens W6 with a Benz inline four-cylinder engine, 2,660 cubic centimeters, producing 50 horsepower. Top speed climbed to 115 kilometers per hour. Reliability improved considerably, but the buying public had already made its judgment. Too strange, too unfamiliar, too far from what people believed a car should be. Now, let's talk about the aerodynamics in proper detail, because this is where the Tropfenwagen transcends its commercial failure and becomes genuinely historic. The drag coefficient was 0.28. That number wasn't confirmed until 1979, when Volkswagen engineers got curious and rolled a surviving Tropfenwagen into their modern wind tunnel. They were expecting respectable numbers for an early 20s automobile. They were not expecting the car to be competitive with their current production models, but it was. 0.28. Frontal area of 2.57 square meters, about 27.7 square feet, for perspective. A Fiat Balilla from the mid-1930s had a drag coefficient of 0.6, more than double the Tropfenwagen from a car built over a decade later. Volkswagen's own Passat didn't match 0.28 until 1988, 67 years. A sixth-generation Chevrolet Corvette, designed with computational fluid dynamics, modern wind tunnels, and decades of accumulated aerodynamic knowledge, managed 0.34. Worse than a car built in a converted airplane factory with a slide rule and hand-shaped models. Both came more than a decade after 1934. Both came more than a decade after Rumpler, and neither achieved his drag numbers. How did he do it? Every element of the car contributed. The teardrop planform shape was the dominant factor. Viewed from above, the body narrowed dramatically toward the rear, forming a trailing vertical edge where the exhaust pipe was neatly tucked away. The cabin roof mirrored this tapering, also narrowing to a point. This extreme boat-tailing is what prevents airflow separation. When air flows over a blunt rear end, it detaches from the body and creates a turbulent wake, a low-pressure zone that effectively sucks the car backward. Rumpler's taper eliminated most of that wake. The curved glass was essential. Flat windscreens and flat side windows create abrupt geometric transitions that trip the airflow and trigger separation bubbles. Rumpler's single-plane curved panels let air slide smoothly around the passenger compartment without disruption. The disc wheels eliminated the considerable drag from exposed wire spokes spinning through the air at speed. Horizontal mudguards presented a fraction of the frontal area of conventional arched fenders. The smooth undertray prevented turbulent airflow from being trapped and dragged beneath the car, which is a major drag source on vehicles with exposed underbodies, and the rear diffuser accelerated the air flowing underneath, lowering the pressure below the car and generating a degree of downforce. Every single one of these features is standard practice in modern automotive aerodynamics. In 1921, not one of them existed on any other automobile anywhere in the world. Rumpler conceived the entire integrated approach from scratch. translating principles he'd used to make airplanes fly efficiently into principles for making a car push through air with minimal effort. But the Tropfenwagen's most important legacy wasn't the car itself. It was what happened when other engineers saw what Rumpler had achieved with so little power. Hans Niebel, chief engineer at Benz and SIA, was paying close attention. 70 miles per hour from 36 horsepower. That number screamed aerodynamic advantage. Niebel studied a Rumpler chassis in detail, understood the layout and the physics, and by 1923 had built the Benz Type RH, a dedicated racing version of the concept. RH stood for Rennwagen mit Heckmotor, racing car with rear engine. It was the world's first purpose-built mid-engine race car. Niebel and his chassis designer, Max Wagner, kept Rumpler's fundamental layout, the mid-engine position, the teardrop shape, even using the virtually unchanged Rumpler chassis as a starting point. But they replaced the little W6 with a proper racing engine, a 2-liter twin overhead cam, inline-six with 24 valves, twin Zenith carburetors, roller-bearing crankshaft, and electron pistons. 90 horsepower at 4,500 RPM, unblown. The engine and 3-speed gearbox sat as a compact unit between the cockpit and the rear axle. The brakes were mounted inboard at the rear to reduce unsprung weight, and the radiator was placed on a crescent-shaped cowl above the engine, behind the driver's head, preserving the clean nose and anticipating the engine airbox designs that Formula One cars would adopt in the 1970s. The car weighed 745 kilograms. Top speed reached 185 kilometers per hour, about 115 miles per hour. 3 Benz Tropfenwagen racers lined up at the Grand Prix of Europe at Monza on September 9, 1923. Drivers Fernando Minoya, Franz Herner, and Willy Walb faced the dominant supercharged Fiats. The Benz cars had no supercharger. 90 naturally aspirated horsepower against significantly more powerful opposition. On raw power, they had no business being there. But the handling, the mid-engine layout, and low drag gave the Benz Tropfenwagen a balance and cornering ability that the front-heavy conventional cars couldn't touch. Over 80 laps at Monza, Minoya finished 4th and Herner 5th. Walb retired with engine problems. The top 3 were Fiats with superchargers, but the gap between the winner and 3rd place was about 5 minutes. Minoya, in 4th, was 4 full laps behind, proof of the power deficit, but the fact that the car finished at all, and finished ahead of several more powerful competitors, was a testament to the fundamental rightness of Rumpler's concept. The Monza organizers awarded Benz a special medallion for the audacity of their engineering. The cars continued racing in smaller German events. Walb and Adolf Rosenberger scored wins in hill climbs and local races. Rosenberger won the Tropfenwagen's final race at the Solitude Road Race near Stuttgart in May 1925. But without forced induction, the cars couldn't keep pace at the highest level. The consequences rippled outward for decades. Financial strain from the mid-engine experiment and poor sales of mid-engine road cars helped push Benz into a merger with Daimler in 1926, creating Daimler-Benz, parent of Mercedes-Benz. So, in a roundabout way, the Tropfenwagen concept contributed to the creation of one of the most famous automotive brands in history. Niebel became chief engineer of the merged company, where he remained influential until his death in 1934. Ferdinand Porsche, who had been Daimler's chief engineer and had certainly studied the Tropfenwagen closely, left in 1928 to start his own firm. One of his first business partners was Adolf Rosenberger, the man who had raced the Benz Tropfenwagen and spent years praising its handling. When Porsche designed the Auto Union Grand Prix cars of the 1930s, the mid-engine layout was a direct descendant of the Benz Racer, which was itself a direct descendant of Rumpler's road car. Several of Rumpler's own engineers, ended up working on the Auto Union project. The chain of influence is remarkable. Tropfenwagen to Benz Type RH to Auto Union, swing axle patent to Volkswagen Beetle, transaxle concept to every rear-engine Porsche ever built. One engineer's ideas, generated in a small Berlin factory in the early 20s, flowing through the entire history of automotive and motorsport engineering. But Rumpler himself saw almost none of this legacy take shape. In 1926, Rumpler Werke AG Berlin went bankrupt and was liquidated. The unsold Tropfenwagens sat in storage, orphans of a commercial failure. That same year, the German film studio UFA was producing Fritz Lang's science fiction epic Metropolis at nearby Potsdam-Babelsberg. Lang needed futuristic vehicles for his dystopian city, set in a distant future year. The year he chose? 2026. Yes, really. The bankrupt Tropfenwagens were cheap to acquire and looked like nothing else on any road. They were the obvious choice. In the film, scale models of the Tropfenwagen populate the soaring multi-level highways of Lang's imagined city. The car so strange that nobody would buy it became the prop so futuristic that a filmmaker chose it to represent transportation a century hence. And here's the detail that stings. Lang set Metropolis in the year 2026. The only car that looked futuristic enough was one that had just gone bankrupt because people thought it was too weird. In one of the film's climactic scenes, real full-size Tropfenwagens were piled into barricades by rioters and set ablaze. The studio bought the remaining unsold cars and burned them on camera. Engineering decades ahead of its time, reduced to kindling for a fictional revolution. That is the primary reason only 2 Tropfenwagens survive today. Rumpler pushed forward after the bankruptcy. In 1930, he designed 2 streamlined delivery trucks for the Berlin newspaper publisher Ullstein. One carried a Maybach inline 6-cylinder with 100 horsepower. The other had a 200 horsepower V12 engine and could reach 100 kilometers per hour. Only 2 were ever built. Both were destroyed in a 1943 Allied bombing raid on Berlin. The pattern was becoming tragic. Everything Rumpler created seemed destined to burn. And then there is the darkest chapter. Edmund Rumpler was Jewish. When Adolf Hitler took power in 1933, Rumpler was arrested and imprisoned. He was released relatively quickly, but it made no difference. His career was finished. Every professional connection, every avenue for his engineering brilliance was systematically severed. The Nazi regime didn't merely end his working life. They destroyed his records, design documents, patent files, technical archives, correspondence, gone, deliberately erased. The government that would build the Autobahn, the very type of high-speed road network that would have finally made the Tropfenwagen's low-drag efficiency practical and valuable, erased the man who had pioneered the thinking behind it. Edmund Rumpler died on September 7, 1940, in Zuesau, near Wismar, in northern Germany. He was 68 years old. He died in obscurity, stripped of his professional identity, his factory long gone, his cars burned or dismantled, his documentation intentionally destroyed by the state. Today, 2 Tropfenwagens survive. One sits in the Deutsches Museum in Munich, a personal gift from Rumpler to the museum before his world collapsed. The other is in the Deutsches Technik Museum in Berlin, displayed in their aviation section. They sit behind glass, silent and alien-looking, exactly as strange and remarkable as they must have appeared on the floor of the Berlin Motor Show more than 100 years ago. Every modern car on the road carries a piece of what Edmund Rumpler figured out. Every curved windshield, every smooth undertray, every carefully shaped side mirror, every computational fluid dynamic simulation, every wind tunnel session, every drag coefficient target set in every automotive design studio on the planet traces a conceptual line back to an Austrian airplane builder who wasn't allowed to build airplanes anymore, and decided to create the most aerodynamic car anyone had ever seen instead. He was too early. The roads weren't ready. Germany's road network in the early 20s was largely unpaved, where aerodynamic efficiency was meaningless. The public wasn't ready. They wanted cars that looked like cars, not spacecraft. The cooling technology, the materials, the highway infrastructure needed to exploit low drag at speed. None of it existed yet. He built a car for a world that wouldn't arrive until decades after he was gone. The autobahns that would have made his design practical. The computer tools that would have let him optimize further. The public taste that would eventually embrace sleek forms. All of it came later, and when that world showed up, his name had been deliberately erased from history. The Tropfenwagen didn't fail because it was wrong. It failed because it was right too soon. And the man who created it didn't fail either. The world failed him. And there you have it. The Rumpler Tropfenwagen. A car from 1921 that Volkswagen couldn't match until 1988. If you think I missed something, or you've actually seen one of the two survivors in a museum somewhere, drop it in the comments. And if you made it this far, subscribe. We do this every week.